Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 3 Chemistry class. You're welcome for today's lesson. I'm Teacher Scovia, your chemistry teacher as always. So today we are continuing with the Unit 1, Lesson 2. You remember in the previous lesson we were introducing the topic, that is carbon and its inorganic compound. But for today we are continuing to look at the allotropic forms of carbon and their physical properties. All right? Remember here we had talked about the word allotropy. We had tried to define the word allotropy, and we said allotropy is what? Who can remind us? Allotropy? Yeah, the existence of an element in two or more than two forms. There we tried to look at some of the elements apart from carbon that exist in form of allotropy. We talked of sulfur, we talked of phosphorus, that also exist as allotropy. But for our case here, we are continuing to look at the forms of carbon, the different forms of carbon, the allotropes of carbon. So you remember for the case of carbon, we said carbon has got two forms. Those are the crystalline form and non-crystalline form. We had tried to say the crystalline forms are graphite and diamond. Those are the crystalline forms of allotropes of carbon. So we also talked of non-crystalline, or those that don't have shape, the shapeless, the amorphous call it. They mean the same, of carbon. Under that, we talked of charcoal, we talked of soot, lambrack, and many others. Those are forms of non-crystalline forms of carbon. For our case today, we are looking at the last time we talked of diamond, we had tried to look at the forms of carbon, a lot of forms of carbon. We started by looking at graphite. The crystalline form, those are diamond and graphite, but we had just looked at diamond. Today we are continuing with graphite. And then the next lessons we shall continue with the non-crystalline forms of carbon. All right? So today we are looking at a crystalline form of carbon, which is graphite. The other time we looked at diamond. All right? So what is the objective of the lesson? The objective of the lesson is to name the allotropic forms of carbon and relate them with their properties. So we're looking at graphite today. We're looking at graphite. We're going to look at the physical properties of graphite. Then we relate the physical properties of graphite with its use. All right? We relate the physical properties with the uses. How it is the structure of graphite, relate it with the functions or the uses it performs. All right? So that's what we are specifically going to look at. So I think everybody is ready, as I can see, with a pen and a book. I'm going to write whatever you feel is very important for you as we are discussing or we are studying under this lesson. So be ready and try for what we are going to share together here. All right? Good. So try to be very attentive and follow the lesson. So graphite, that is the structure of the graphite as you can see on the slide. So the carbon atoms are joined by a weak force, the van der Waals forces. All right? So carbon, in graphite, the carbon atoms are also bonded by this covalent bond. All right? But here for this case, the carbon atom is bonded to 3 other carbon atoms by a strong covalent bond, but another space remains. Right? So there's one, the 4th atom is not bonded. It has a free electron. Call it delocalized electron. All right? Now, that delocalized electron will keep moving within the structure. It's among those in the structure, but it is not bonded. All right? Giving graphite one of its importance. All right? Being that it has a delocalized electron, as we are going to see to the uses. That free electron that moves, will help it to be a good conductor of electricity, which is not the case for diamond. We said for the case of diamond in the previous lesson that diamond, a carbon in diamond is bonded for carbon atom, whereby a diamond does not have any free electron. So it is not a good conductor of electricity, because in conduction of electricity, as we studied, it is favored or it is done by the free electron, the localized electron. So since for diamond there is no free electron, graphite does not conduct electricity. But for the case of this graphite there, because for it, it has a free electron. Only 3 atoms are bonded to a carbon atom, and they will remain with a free electron, which helps in conduction of electricity. All right? Good. So that one gives it a hexagonal structure. Hexagonal structure. Remember, for the case of diamond, it is tetrahedron. But this one is a hexagonal structure whereby the layers or the carbon atoms are held by a weak van der Waals forces. All right? Good. That is the structure generally for graphite. So we're going to look at the physical properties. The physical properties of graphite. Graphite is a soft, black, and shiny material with a greasy feel. When you touch on it, greasy? Something like if you touch on this gel that you use for smearing, that one is greasy. That one also will give it its function, as we're going to see in the uses. So graphite is easily breaks off. Another use, graphite has another physical property. It has relatively high melting and boiling points due to the strong covalent bonds joining the atoms together. Yeah, I said this. Like diamond, being the hardest substance due to the presence of the covalent bond between carbon atoms, also graphite, the carbon atoms in graphite are joined by a strong covalent bond, which gives it also to be with a relatively high melting and boiling points, but not to that of graphite, a diamond. All right? So the density of graphite is 2.25 grams per cubic centimeter. So graphite is a good conductor of electricity due to the presence of the localized electron in its structure. I mentioned this. I said graphite, the carbon atom of graphite is only bonded 3 other carbons by a stronger covalent bond, and we have a free delocalized electron. All right? So that presence or that delocalized electron of graphite will help in conduction of electricity. So it is a good conductor of electricity. So graphite is opaque. It is opaque. Who can remind us opaque? The word opaque, just an English word. Opaque means light cannot pass through. All right? Good. But for the case of diamond, we said it is transparent. But this one, graphite, is opaque. Light cannot easily pass through. All right? So it is not very easy for light to do what? To penetrate graphite, as the case for this diamond, because it is transparent. So those are features of the physical properties of graphite. So you remember the objective is to relate the physical properties with the uses. So if we have understood very well the physical properties of graphite, being soft, black, shiny material, being with relatively high and boiling and melting point, a bit higher density of 2.25 grams per cubic centimeter, having only 3 carbon or having a delocalized electron, and being opaque. What do these physical properties contribute to its uses? All right? That is the next thing that we are going to see. The properties of graphite determine its uses. That's what I've started with. The properties of diamond determine its uses. All right? The structure, the property. Remember the objective. We always study under objectives. Right? The objective is here. Relate their properties and their uses. You relate their properties and their uses. That's what we are looking at. We have finished looking at the properties. Now we're going to relate these properties with the uses now. 1, it is used as electrodes in dry cells and fuel cells. Why? Because it is a good conductor of electricity. What gives it to be a good conductor of electricity? The presence of the free electron. All right? Good. Another use of graphite is that graphite is used as a carbon laser in the production of steel. So it gives steel its strengthening characteristic. So another use is that it is used in advanced high friction applications such as car brakes, crashes, because of its high thermal and electrical conductivity. All right? So another use is it is used to make pencil leads. You know the pencil leads? You know a pencil, this normal pencil that you use for drawing and whatever. That everybody check from your pencil and see. That small black in the middle, the one normally when you try to force it or to place it hard on the paper, it breaks. That black thing that you use for writing, that's what we call the pen leads. So that one is graphite. It's made of graphite mixed with clay. Just clay, mix graphite, then you get the pen lead. Why? This is due, so we're bringing the future, or the characteristic, or the physical property. Why? Why is it used in writing and making the pencil lead? This is due to the sliding of its layers, which enable it to slide on paper when writing. Now, if it was like a metal, take an example of a nail, just a nail, use it for writing. Can it write? When you get a nail, it cannot write. Why? It doesn't have that feature of layers, arranged layers that can slide on a paper when you're writing. So that is a physical property that determines its use. Another use of graphite, so at high temperatures, at high what? At high temperatures, graphite can be used as a lubricant in places of grease or oil. Why? This is because graphite has a high boiling point. Remember we said in the physical properties of graphite that graphite is glisten, right? It is glisten. So when you apply it in car brakes, and it is at high temperature, it can boil, it has a high boiling point, it can easily work effectively instead of using the grease or oil. All right? Good. So another property that another use that is brought as a result of its a feature or its property, physical property, is the production of paints and shoe polish. Use number 6. The production of paints and shoe polish. You remember in the physical properties, we said it is black. So when they want to make this black shoe polish, they will apply graphite. So the powdered form of lamp graphite is used due to its natural water repellent property. So when you put water, it can repel water, act as a proof. Water cannot easily penetrate. So it is the best choice for giving a protective coating on wood or shoe leather. So when they are making shoe leather or shoes from leather, they try to coat or to cover them with graphite because of, remember, sometimes you can be walking, coming to school, going to visit a friend, then it happens to rain. You wouldn't like it if the shoes you are putting in, the water just penetrates in. So for the case of graphite, when it is put as a coat on the shoes, just repels water. Water will be just flowing off. All right? Good. Number 7, another use it is used in different sectors or in different ways. It has very many uses. So it is used to make furnace linings, brushes for electric motors and generators. That one is very clear. Another thing, the other use of graphite is used as a modulator in nuclear reactants. So when they are trying to make the nuclear bombs and whatever, it is used as a modulator in nuclear reactants. All right? That is the case of graphite. So we are heading to another kind of non-crystalline form. When you look on the structure there, what I'm trying to see on the slide here, yeah, it's charcoal, the normal charcoal we have been talking about. So this charcoal is used also as, or it is put under the non-crystalline forms of carbon, as I had mentioned in the introduction of the lesson. So that is charcoal. So we are saying that the non-crystalline forms of carbon, are formed by decomposing other substances like wood, high temperature. So charcoal is inclusive. So when you get wood and you decompose it at high temperature, you know how to make wood? Have you ever seen where they are making, charcoal, where they are making charcoal? You remember that? Who can try to tell us? Yeah, you just cut the poles of a tree, you gather them in a small press, gather them, cover them with soil, then they leave a small entrance, small air entrance, then they introduce in fire. But why do you think they have to cover? They have to cover such that they limit the oxygen. So they do what we call incomplete combustion. Limited oxygen. If they would introduce enough oxygen, the wood would all get burnt to ash. That's why they have to cover, introducing limited oxygen. There they form a charcoal. This charcoal, I've tried to show you on the slide. This charcoal here. That's how it is formed. They gather the wood, cover them, leave a small hole or a small entrance, introduce in fire. But try to visit people who do this, you will see, in the villages and the nearby places. We shall try to go there and see. So introduce in fire, then they will get burned slowly by slowly, as I said, by incomplete combustion. And that one, we call it destructive distillation. So it can be done for, there are two types of charcoal, obviously. We have the wood charcoal and animal charcoal. The wood charcoal is got from the wood as the name. The animal charcoal is from the gathering of animal bones. So they gather animal bones, as for the case of the woods, under destructive distillation, they also get charcoal, animal charcoal. So the physical properties of charcoal, as you are seeing, charcoal is black. That one is obvious, everybody can see this. It's black. It's black, polar solid. It is a bit soft. If you compare it with diamond and graphite, it's a bit soft and has a low density. It can absorb large volume of gases and solids. Those are the physical properties of charcoal. So what are the uses of charcoal? So everybody knows this. At your home, at our home, we use charcoal as a source of fuel, mostly here in developing countries. Rwanda, Africa inclusive. We use charcoal, but normally we use wood charcoal, not bone charcoal, but bone charcoal also do, animal charcoal do exist. So another use is that activated charcoal, that is charcoal that is finally powdered. You get charcoal and then you make it a powder. So activated charcoal is used to remove smell gases in slaughterhouses, gas manufacturing plants, large air conditioning systems, and airports. So that is it. The powder that is made from charcoal is used in those areas. All right? The lamp black is used in making the black ink, paints, carbon paper, carbon paper where they use for writing. You write on a paper, put him in the middle, that carbon paper. What you are writing can be seen on the down paper. So it can be used as a carbon paper and as an ingredient in the rubber tires. All right? That is the lamp black. You know the lamp? The lamp, that one was used in some days back. Used to electric bulbs and whatever, electricity. But in days back, people, even in villages per now, I think it is there are the lamps. They use the lamps for lighting at night. So the lamp black is those things, there are things that comes off, that goes off as because the lambrac has got a kind of a thread in the middle in a form of a cross, so it gets burnt slowly by slowly. So those brack things that goes off, those are the lambrac. So they can be collected and used in making the brack ink, paints, carbon papers, and as ingredients in rubber tires. All right? Good. So that's what our objective was, to look at the physical properties of some of the forms of carbon, the allotropes of carbon, and then we relate them with their uses. As for today, we have been looking at graphite, and we have also looked at some of the amorphous carbons, the non-crystalline forms of carbon. Those are the wood, the charcoal, the wood charcoal and animal charcoal. We have also looked at the lambrac and its use. All right? So this is a small worker that I'm leaving behind for you to do in your free time. So when you're trying to do this, you will let them, or you will just try to read back the slides or the notes that we have been talking about, that we have explained. So the first question, there are only two questions here. So the first question, explain why graphite is used as a lubricant, whereas diamond is not used. So we looked at the feature or the physical property of diamond, that it is greasy. So it can be used as a lubricant, but why diamond cannot be used? Another question is number 2. You give and explain the uses and properties of graphite. All right? So you should first talk of the use, the property of graphite, so you lead them to the uses of graphite. Because we said the uses of graphite are brought about as a result of its properties. So it's the property that gave the uses of graphite. So it will be very easy for everybody there. All right? So try to attempt those 2 questions in your free time. So we have enjoyed the lesson. Thank you so much for your good attention. Let's meet in the next lesson. Thank you so much for your good attention. A nice time. Bye.